Hello, Chemist Corner. Today's video is a little bit different. It's a series of 3 different demonstrations that I use to train my Chemistry 11 students how to observe. The intended audience is the beginning chemistry teacher who wants some very easy demonstrations to do in the lab. In the video, first I show some demonstrations that you can give to your students if you don't have access to the chemicals yourself, followed by some questions you can ask them to help direct their thinking to become better observers. And the last half of the video, I show you how to set up the actual demonstrations. I hope you enjoy. Learning to observe. In this activity, your task is to make unbiased observations. What do you actually see? Is this a physical or a chemical change? Use your observations to create an explanation or a hypothesis for what you are observing. Demonstration number 1. What do you think you see is happening here? Here are some questions that you can ask yourself. What was in the beaker to begin with? What are you observing now? When did the color actually change? Was it when I picked up the first beaker? Was it when the liquid left the beaker? Was it when the liquid entered the second container? Or was it when the liquid hit the bottom of the second container? Look again more carefully. Ask yourself those questions. When did it change? Where did it change? Demonstration number 2. Were the two liquids actually colorless? What is the difference between clear and colorless? Is the yellow a uniform color, or is there some texture in there? Try to describe the clarity. Watch again in slow motion. When did that change color? At the top of the second or at the bottom? Demonstration number 3. The things you can't tell in this. Is there any odor? Any change in temperature? What do bubbles actually indicate? And based on what you're observing, what's a reasonable guess for the bubbles that have been involved here? Is the gas toxic? Is it colorful? Watch again in slow motion. When did the bubbles start to form? Have you ever seen something like that before? Does that look familiar? So what really happened? How to prepare demonstration number 1. The clear colorless solution can be any basic solution at all. In the beaker that looks empty, I put a couple of drops of phenolphthalein. Now don't put in too much, just put in a couple of drops, swirl it around so that the phenolphthalein stays in the ridge. If you put in too much, the students will be able to see some of the residue. You don't want them to see that. Make up a solution of some hydroxide, could be a sodium or a lithium hydroxide or a potassium hydroxide. The concentration doesn't matter. All you need it to be is basic. Basic enough to turn phenolphthalein pink. Now, when you mix it together, ask the students, when did it change color? Was it going through the air? Was it going into the beaker? Or when it hit the bottom? Therefore, what's the conclusion? You might see some mousy lines in there where the phenolphthalein is a little more concentrated. The other thing that the students will not notice the first time is that the color fades over time quite rapidly. After a minute or two, no more color. Demonstration number 2. What really happened? You had 2 clear colorless solutions. Well, one of the solutions was a dilute solution of potassium iodide. It doesn't take much. just a little bit of potassium iodide dissolved in distilled water. The other solution is lead to nitrate. You need very, very little lead. Again, just a few crystals with distilled water, stir it up, let it sit. Do be careful if the potassium iodide is too old, it's been around for too long, it will be discolored. There will be a slight yellow hint of I2 forming in there. Pass it around, ask the students to smell it. Is there any odor? Is there anything else that you see besides it looks like water? Once again, when you pour one into the other, ask them, when did it change color? When it hit the top of the water or the bottom of the water? After time, the lead to iodide solid will settle to the bottom. Initially, it's uniform. After half an hour, there will be definitely layers to be observed. The third demonstration. Simple reaction between a carbonate and any acid. Start with a relatively concentrated solution of hydrochloric acid. Vinegar will work as well if that's what you've got. And then dissolve up a little bit of carbonate into water. It could be a potassium carbonate, a sodium carbonate, even sodium bicarbonate, baking soda, will work in a pinch. Dissolve up your sodium carbonate into water. The more concentrated you have, the more bubbles, of course, you'll generate later. Make sure it's well dissolved so that the students can't see any solid in the bottom and it just looks like water again. Doesn't matter which one you pour into which, just combine them and you'll get that very quick bubble formation. Well, then ask the students, what do you think the gas is? The fact that I did it in my hand, right under my nose, tells you it's not toxic. The fact that it's not colorful tells you it's not chlorine. What gas do you think I evolved here? Have you ever seen something that looks like this, like a soft drink? What did you observe? That's the key. If there was a color change, that is evidence for a chemical change. Was there a change in clarity? If so, something is suspended in that liquid. Did you see bubbles? That's evidence for gas formation. Did you see solids suspended in your liquid? Then something was formed that had low solubility in water. What did you actually observe?